This is a short video on double replacement reactions that we covered in class yesterday. Double replacement reactions are one of the four key reactions in chemistry. The other three being combination or synthesis reactions right here, or decomposition reactions, or single replacement reactions. Super quick, just so you can remember. Combination reactions are A plus B gives you AB, so you're combining or making synthesis. Decomposition would be a compound AB decomposes into its initial materials, A plus B, where A and B are different elements of a compound. Single replacement is like A plus BC results in the products of AC plus B. So you can see you replaced one single element. C goes with A instead of with B. And therefore, double replacement reactions, you can see that the starting materials AB, right? AB are two different elements, plus CD, two other elements, give you AD plus CB. So the things that switch in the double replacement reaction are the second components. So this B now goes with the C, and the D goes with the A. So AD and CB. So what does that mean when you're talking about actual chemical reactions? Okay, so we're going to use this example to talk about a double replacement reaction, and this is from the worksheet that I gave you. So we have lithium sulfide plus silver nitrate, and the NO3 nitrate, that's a polyatomic ion, so I'll consider that almost like one element or one unit. So what we have here is we have lithium, Li, which would be considered like the A, and then sulfide is the B, and then silver, Ag, is the C, and then NO3 nitrate would be the D. And then we saw with the other part, AB plus CD equals, or yields AD, because we're switcherooing the second component, so we're switcherooing these things, right? So we have AD plus, what do we have? AD plus CB, okay? So that's our products. So if we go on to think about this chemical equation that we have here, the answer would then be, we're going to keep the A where it is, so lithium, just like it is, and lithium's going to be attached to the D, so that's NO3. And then the silver, Ag, which is considered the C. Let me make this go over here where the C is, right? The C. The Ag is going to be the C. And then that's going to be attached to the sulfur, S. Oh, something weird there. So, I don't know why that happened. Okay, so that's basically the double replacement reaction, but we're not done yet because we have to make sure that we have the right number of atoms in our formulas. And how do we know that? And that's this thing over here called the crisscross rule. So in the crisscross rule right here, crisscross rule, we're going to crisscross the charges just like they said. And so what we're going to do is, so lithium, if I go to the periodic table, you can see that lithium here is in group 1, right? So, and group 1 is going to always have a +1 charge, +1 charge. See, I'm going to make that thicker. Okay, and then in group 2 is always going to have a +2 charge. These transition metals, they're funny. They could have a number of charges, and that's why when we name transition metals, we always try to put the charge in the actual name. Group 13 will have a +3 charge. 14 is +4 charge. 15 usually has a -3 charge, although that can be a little iffy. 16 almost always has a -2 charge. 17 has a -1 charge, and 18 is like 0. This is not right. So if we go back to the equation that we were talking about, we can remember that lithium here was in the first group, column 1, and so that is going to have a charge of +1, and sulfur is in the group 15, and so it's going to have a charge of -2, and silver is +1. And if you look at table E, you'll see that NO3, which is nitrate, has a -1 charge, which will just have a negative line like that, so -1. So we want the charges on each compound to be neutral, probably. So there's this thing called the crisscross. So I'm going to take whatever number is up here, and I'm going to bring it down here. So that's a 2. And this is a 1. It's always going to be positive. So that's how I get Li2S. And then silver nitrate, it's just 1 and 1, and of course just the absolute value of each number. So if there's no number there, that means 1 of that element. So on the product side, these, as you remember, are products, right? On the product side, this has a -1 and this has a +1 charge. So they even each other out, so I don't need any changes in the subscripts there. Sulfur has a -2. We said that before. Silver has a +1. So I really do need, I'm going to crisscross this down. I really need 2 silvers, and I'm just going to have 1 sulfur, so I'll just leave it like that. So my final equation reaction is Li2S plus AgNO3 gives you lithium nitrate plus, let's see if I could put the Ag2, this should be an Ag2S. Let me change the color. Go back here. Ag2S. Okay, so that's the crisscross rule. And in the worksheet for each one, you were to write the final product.